Welcome to ThinkViL educational videos. In this video, we will learn about cars' relative motion and relative motion, covering their theory, key concepts, important formulas, and practice questions. First, let's understand, what is cars' relative motion? Cars' relative motion is the example of relative motion that describes the movement of one car as observed from another moving car. It depends on their speeds and directions. Cars' relative motion, ThinkViL simulation is based on the concept of cars' relative motion. Now, what is relative motion? Relative motion is the movement of an object as observed from another moving object, and it is described by relative velocity. It depends on the observer's frame of reference. For example, relative motion of cars and rain-person problem. Now, what is frame of reference? A frame of reference is the point or place from which we observe and measure motion. It helps us describe how objects move. There are two types of frame of reference. First is the inertial frame of reference, where the observer has no acceleration, meaning the observer is either at rest or moving at a constant velocity. For example, girls playing inside a smoothly moving train. So for girls, train is the inertial frame of reference. Now, the second is the non-inertial frame, where the observer experiences acceleration. For example, a sudden brake in a bus causes passengers to lurch forward. Now, what is relative velocity? Relative velocity is the velocity of an object as observed from another moving object. It is the difference between their velocities and depends on the observer's frame of reference. Now, we can understand the relative velocity in two ways. The first is relative velocity in one dimension, which can be in same or opposite direction. The second is relative velocity in two dimension. Let's understand relative velocity in one dimension. First, take the case of same direction. Let's understand this using cars' relative motion ThinkViL simulation. For access the simulation, visit www.thinkvil.com. Now open the simulation, you will see this layout. Here, this is the ground, the red car, the observer, and the blue car. Here, the motion is in one dimension, means no velocity in y direction. And in this case, both cars have velocities in the same direction. Now, provide the different velocities to both cars. From here, you can change the position of the observer, meaning you are on the ground or in the red car or in the blue car. Remember, here you are the observer, which means you will observe exactly the same motion on the screen as the observer sees in real time. Now first, the observer is on the ground. Now start the simulation. Now, observe the motion. If I change the observer's position to the red car, now, observe the motion. Now, change the position to the blue car. Now, observe the motion. In all cases, the observer sees different velocities, which are the relative velocities with respect to the observer. Let's assume the ground, red car, observer, and blue car have the following velocities with respect to the ground. Now, these are the relative velocities with respect to the observer. Let's find out the relative velocities when observer is on the ground. Now, the relative velocities when observer is in the red car. Now, the relative velocities when observer is in the blue car. Let's understand the relative motion in opposite direction. Now, if we change the velocities to be in opposite directions. Now, observe the motion when observer is on the ground. Now, observer is in the red car. Now, observer is in the blue car. Here, we can observe the different relative velocities with respect to observer positions. Now, assume variables to find out the relative velocities. Now, you will get the relative velocities when observer is on the ground. Now, relative velocities when observer is in the red car. Now, relative velocities when observer is in the blue car. Let's understand the relative velocity in two dimensions. Now, we have velocities in both the x and y directions. Now, observe the motion when observer is on the ground. Now, observer is in the red car. Now, observer is in the blue car. Here, we can observe the different relative velocities with respect to observer positions. Let's assume the velocity with respect to the ground. Since the motion is in both the x and y directions, we can express the velocities in vector format. Now assume variables to find out the velocities with respect to observer. Here, you will get the relative velocities when observer is on the ground. Now, you will get the relative velocities when observer is in the red car. Now, you will get the relative velocities when observer is in the blue car. Let's take an example. In car's relative motion, the red car has a velocity vector Vr is equal to 5i cap plus 10j cap, and the blue car has a velocity vector Vb is equal to 10i cap plus 10j cap. Now, determine the velocities of the ground, red car, and blue car with respect to the observer when the observer is on the ground, in the red car, in the blue car. Let's first visualize the question in car's relative motion ThinkViL simulation. Now, open the simulation. Provide the given inputs for the red and blue car. Now, first choose the observer's position as on the ground. Here, you will get the relative velocities with respect to observer. Now, change the observer position to the red car. Here, you will get the relative velocities with respect to observer. Now, change the observer position to the blue car. Here, you will get the relative velocities with respect to observer. Let's solve the question with formulas. Here we have given velocities of red and blue car. There is no movement in ground, so velocity of ground is 0. Now take the first case when observer is on the ground. Here observer velocity is also 0. Now use relative velocity concept to find out the relative velocity of the red and blue car with respect to observer. Now, the observer's position is changed to the red car. Here, the observer's velocity will be the same as that of the red car. Now use relative velocity concept to find out the relative velocity of the ground and blue car with respect to observer. Now, the observer's position is changed to the blue car. Here, the observer's velocity will be the same as that of the blue car. Now use relative velocity concept to find out the relative velocity of the ground and red car with respect to observer. After all the calculations, you will get the same answer as in the simulation. Thanks for watching the video. For access more educational resources, visit www.thinkvil.com. And don't forget to like, subscribe, share, and press the bell icon for more updates.